Alright, so this is going to be the video for Chapter 4 of Wireless LANs for the course, whose hashtag is right here. Starting off with what is a wireless LAN. A wireless LAN is a classification of wireless networks that is commonly used in homes, offices, and campus environments. After that, we have wireless concepts, and it's important to know that there are some serious benefits to using a wireless type of infrastructure over a physical one, and some benefits include mobility, increased corporal productivity, and adaptability to new technology. Some common wireless technologies that I think we're all familiar with are Bluetooth, cellular broadband, satellite, Wi-Fi, and the newer WiMAX. A wireless personal area network, or WPAN, operates in the range of a few feet. Bluetooth or Wi-Fi direct enabled devices are used in WPAN. Wireless LANs, which is what we're going to be focusing on in this chapter, operate in the range of a few hundred feet, such as in a room, home, office, or even a campus environment. And wireless wide area networks operate in the range of miles, such as a metropolitan area like a city, a cellular hierarchy, or even on inner city links. After that, I think it's important to mention that Bluetooth is originally a 802.15 WPAN standard that uses a device-varying process to communicate in very small distances, 0.05 miles or 100 meters. Wi-Fi, which is what we commonly know any wireless communication as, it means wireless fidelity, and it's a standard that provides access up to 300 meters. And WiMAX is up to 50 kilometers, and as you can see, it is very much so a lot higher than the rest. After that, we have cellular broadband, which is what we know as our cell phone's sort of internet service. It consists of various corporate, national, and international organizations using service provider cellular access to provide mobile broadband network connectivity. It was first available with second-generation cell phones in 1991, and by then it was known as 2G, with higher speeds becoming available in 2001 and 2006 as part of the third and fourth generations. After that, we have the satellite broadband, which provides network access to remote sites through the use of a directional satellite dish that is aligned with a specific geostationary Earth orbit or geosatellite. It's usually more expensive, of course, and does require a clear line of sight. Now, wireless technologies operate using radio waves in the electromagnetic spectrum, and in our case, we're going to be focusing on the ultra-high frequency and above. For instance, WLAN works in a 2.4 gigahertz rate, and after that, we have at 5 gigahertz and at 60 gigahertz. The numbers on the right are just the standard that we're going to be referring to, and we'll get to what all of these individually mean in a second. Now we can compare the standards. The 802.11 is the most common standard for Wi-Fi technology, and as you can see, the basic first released standard had a maximum speed of 2 megabytes and worked at a frequency of 2.4. After that, it's just slight increases, and starting from the 802.11g, you can see that they started adding backwards compatibility between these types of connections. Now, the ITU/R regulates the allocation of the RF spectrum in satellite orbits, and the IEEE specifies how the RF is modulated to carry information. It maintains the standards for local and metropolitan area networks with the IEEE 802 standard that we're all familiar with. The 802 and the 802.3, those are Ethernet, and the 802.11, that's referring to wireless LANs. Now, as far as certifying that certain devices are Wi-Fi capable, there are a few organizations that do it, but we're going to be focusing on the Wi-Fi Alliance with these logos that I'm sure you've seen maybe once or twice. The first one is the generic Wi-Fi Alliance logo, and it states that the product has been tested and meets the specified Wi-Fi feature. The second implicates that the product will interoperate with 802.11a, b, g, or n devices. Now the Wi-Fi logo, that's third, implicitly says that it's protected setup, which is certified to simplify initial device connectivity. This can be done in several ways, but I think one that we might be familiar with is the button press that allows you to connect while you're searching for the device. And the last one is the Wi-Fi logo that certifies that the device is Wi-Fi direct capable, simplifying the sharing of media between devices. Now we have this small table that compares WLANs versus regular LANs, and as we can see, the physical layer is either going to be a cable if you're on Ethernet, or a wireless LAN is going to be a radio frequency. The media access has collision avoidance and collision detection, respectively. The availability is anyone with a radio NIC and range of an access point, whereas in the Ethernet you need a cable connection. However, in the wireless LAN there is a lot of signal interference that can completely disrupt the connection, while in the Ethernet it's not really that important. And finally, WLAN access can be regulated by country authorities, whilst the Ethernet access is commonly just regulated by the standard. That's the IEEE. Now, the simplest wireless network requires a minimum of 2 devices. Each device must have a radio transmitter and a radio receiver tuned to the same frequencies. At the bottom, we have a couple of examples of very basic and, as you can see, very tiny, completely functional wireless adapters. Now, the one that we're all, I think, more familiar with would be the typical home network, which is where a home user typically interconnects wireless devices using a small integrated wireless router. These smaller integrated routers serve as an access point, a switch, and a router, all at the same time. And as we can see, the ISP sends the internet information to a DSL modem, which is then connected to the wireless router, which provides coverage for commonly an entire house. This is just a sort of more corporate scheme of how you could see a wireless solution being implemented. As you can see, it's going to provide access to the regular wired PCs in the wired network, whilst at the same time allowing clients to connect to an access point wirelessly. Now, an autonomous access point, sometimes referred to as a heavy access point, are standalone devices configured using the Cisco CLI or graphic user interface. Autonomous access points are useful in situations where only a couple of APs are required in the network. Optionally, multiple APs can be controlled using wireless domain services and managed using Cisco Works Wireless LAN Solution Engine. A home router is an example of an autonomous AP because the entire AP configuration resides on the device. And we can compare this to the next type, which is controller-based access points, which are servant-dependent devices that require no initial configuration. Cisco offers 2 controller-based solutions. Controller-based access points are useful in situations where many access points are required in the network. We can sort of look at this as our school. As we can see, in every building there's a series of routers, and you completely need to have 1 or more per floor to provide coverage to every classroom. And they're all managed by a WLAN controller. These are some examples of small business autonomous access points, of course all made by Cisco. And it's also important to mention the Cisco Meraki, which is a cloud managed architecture that requires the following: the Cisco MR Cloud Managed Wireless Access Points, the Meraki Cloud Controller, and the web-based dashboard, which allows you to remotely perform configuration diagnostics on all the access points you have in a certain area. Now, Cisco Aironet access points and Aironet, this is referring to satellite communication. So we have the omnidirectional Wi-Fi antennas, which are factory Wi-Fi gear often used using basic dipole antennas, also referred to as a rubber duck design, similar to those used on walkie-talkie radios. Omnidirectional antennas provide 360-degree coverage and are ideal in open office areas, hallways, conference rooms, and outside areas. Directional Wi-Fi antennas, on the other hand, focus the radio signal in a given direction. This enhances the signal to and from the access point in the direction the antenna is pointing, providing stronger signal strength in one direction and less signal strength in all the other directions. And the Yagi antennas, lastly, are a type of directional radio antenna that can be used for long-distance Wi-Fi networking. These antennas are typically used to extend the range of outdoor hotspots in a specific direction or to reach an outbuilding. Now, wireless LANs can accommodate various network topologies, but there's two main modes that we're going to be focusing on. The first one is the Ad-Hoc Mode, which is when two devices connect wirelessly without the aid of an infrastructure device, such as when you're trying to connect your phone with a friend's phone using Bluetooth or Wi-Fi Direct. Secondly, we have the Infrastructure Mode, which is when wireless clients interconnect via a wireless router or access point, such as in WLANs. Access points connect to the network infrastructure using the wired distribution system, such as an Ethernet connection. This is the summary for ad hoc. As you can see, it's just two devices connecting between each other. There's no need for an access point. As you can see at the bottom, the topology mode is ad hoc. Then it's an independent BSS. There is no access point, and it refers to a basic service area. Then we have a basic service set summary, which is, as we can see, infrastructure. Basic service set's still the same, but now there's an access point, and the service area is still exactly the same. We can improve on that using an extended service area known as ESA, which will require 2 or more access points, as we have, for instance, in our school. It's an extended service set, and it's an extended service area. Now there's the contents of the wireless 802.11 frame header. So you can see your frame control duration addresses and the sequence control, and the specific definition of all the wireless frames are as follows. The frame control identifies the type of wireless frame and contains subfields for the protocol version, frame type, address type, power management, and security settings. Secondly, we have the duration, which is typically used to indicate the remaining duration needed to receive the next frame transmission. After that, we have the addresses. Then we have the sequence control, which contains the sequence number and fragment number subfields. Then we have the fourth address. That's commonly missing because it's only used in ad hoc. And the payload, which is the data for transmission. Lastly, it has the FCS, which is the frame check sequence used for layer 2 error control. Then we have the content of the frame control field, which, as we can see, has even more options. We have the protocol version, the frame type, the frame subtype, the TODS, from DS, more fragments, retry, power management, more data, security, and the reserved fields. So you can see the protocol version. That just provides the current version of the protocol being used. You have the frame type and frame subtype, which determine the function of the frame. The TODS and the from DS indicate whether a frame is going to or exiting from the DS, and is only used in data frames of wireless clients associated with an access point. Then we have more fragments, which is just indicating if there are more fragments. The retry, which indicates whether or not the frame for either data or management frame types is being retransmitted. Power management indicates whether the sending device is in active mode or power save mode, and more data indicates to a device in power save mode the access point is more frames to send. Security, it indicates whether encryption and authentication are used in the frame, and the reserved field can indicate that the received data must be processed in order. Lastly, we have the specifics within each frame type. So in the frame control frame type field, we have the management and control frames, the association requests, and these are basically how Well, for instance, these primary 4 are how you associate to an access point. And we have frame subtypes also. Now, to connect a client to an access point, there's a specific 3-stage process that you have to follow. It starts with discovering the access point, then you authenticate, and then you associate. Of course, there's more to each one, but that's the basic scheme that you have to follow to connect to an access point. Now, these are common configurable wireless parameters in SSID, which is important because it's the unique identifier that wireless clients use to distinguish between multiple wireless networks in the same vicinity. The SSID name appears in the list of all available wireless networks on any client. Depending on the configuration, several access points on a network can share an SSID, like in a school, I think it's Wlan, and names are usually 2 to 32 characters long. As far as the password is concerned, it's required from the wireless client to authenticate to the access point. This can or cannot be in the connection. If it's an open network, when you try to associate with it, it will reply with a yes instead of asking you for a password. And the password in this case is sometimes referred to as a security key. Then we have the network mode, which is just the standards that you're going to choose to follow. And the security mode, which is the extra security parameter settings, such as WEP, WPA, or WPA2. And it's always recommended to enable the highest security level supported. Lastly, we have channel settings, which refer to the frequency bands being used to transmit wireless data. Now, access points can commonly operate using 1 or 2 modes. It's either going to be the passive mode, which is the access point openly advertises the service by periodically sending broadcast beacon frames containing the SSID, supported standards, and security settings. The primary purpose of the beacon is to allow wireless clients to learn which networks and access points are available in any given area, thereby allowing them to choose which network and access point to use. Active mode is a little bit more complicated because the wireless client must know the name of the SSID. The wireless client initiates the process by broadcasting a probe request frame on multiple channels. The probe request includes the SSID name and the standard supported. Active mode may be required if an access point or wireless router is configured not to broadcast beacon frames. After that, we have several types of authentication. We're going to be focusing on open and shared key. As I said earlier, fundamentally a null authentication, where the wireless client says, "Authenticate me," and the access point responds with a yes. Open authentication provides wireless connectivity to any wireless device and should only be used in situations where security is of no concern. It's referring to open authentication. Secondly, shared key authentication is the technique based on a key that is pre-shared between the client and the access points. This is the authentication procedure, being more specific if you do have a key. So the authentication frame contains the type, whether it's open or shared key, and if it's a shared key protocol, it shares the key, what has to send the key rather. And then the authentication frame that is sent back has the type, the key, and whether it was a successful or unsuccessful attempt to authenticate. After this, we can concentrate on the Wlan Security. As we can see, the 4 most common threats are wireless intruders, interceptions of data, rogue access points, and denial of service attacks. And we'll get to these in a second. Accidental interference from other devices, such as a microwave, or in this case a phone, can interfere with wireless communications and thus slow down or completely disable the wireless access, which is called a denial of service, which is not to be confused with a distributed denial of service attack, which is a more complicated instance of cybersecurity. Now, 2 common management frame attacks include a spoofed disconnect attack, or a CTS flood. This occurs when an attacker sends a series of disassociate commands to all wireless clients within a BSS. These commands cause all clients to disconnect and when disconnected, the wireless clients immediately try to reassociate, which creates a burst of traffic. The attacker continues sending disassociate frames, and the cycle keeps repeating itself. Lastly, we have the CTS flood, which occurs when an attacker takes advantage of the CA contention method to monopolize the bandwidth and deny all other wireless clients access to the access point. To accomplish this, the attacker repeatedly floods the BSS with clear to send frames to a bogus STA. All other clients sharing the radio frequency medium receive the CTS and withhold their transmissions until the attacker stops transmitting the CTS frames. Rogue access point is an access point for a wireless router that has either been connected to a corporate network without explicit authorization and against corporate policy. Now you can consider this, for instance, as if you show up at school with a router, you place it wherever you'd like, where it provides the most network coverage for what you're interested in doing, but you do it without authorization and against the school's policy. This would be considered a rogue AP and is dangerous because it can be used for nefarious purposes. For instance, you can use it to capture and disguise data packets, gain access to network resources, or to launch a man-in-the-middle attack, which we'll explain in a second. A man-in-the-middle attack. Now this is interesting, but at the same time very dangerous to consider, because a popular wireless man-in-the-middle attack is called the Evil Twin AP attack. It's where an attacker introduces a rogue AP and configures it with the same SSID as a legitimate access point. Locations offering free Wi-Fi, such as airports, cafes, and restaurants, are hotbeds for this type of attack due to open authentication. That's important because you need to consider, for instance, if you're connecting to the school network and you happen to have maybe more than 3 available, they all have the same name, so in reality you can't really be sure what you're connecting to. You sort of assume that they're all going to be from school. But there can be a chance of one of them being a rogue access point that you're connecting to, and you're going to be sending private and sensitive information to. Now, to address these threats, initially there were 2 early security features that were primarily used. You have the SSID cloaking, which is the access point in some wireless routers, allow the SSID beacon frame to be disabled, which is what we consider manually identifying the SSID to connect to a network, instead of making it publicly available information. Then we have the MAC address filtering, which is an administrator can manually allow or deny clients wireless access based on their physical MAC hardware address. Later on, with the original 802.11 standard, we introduced 2 more security protocols, which you've already seen, but it's important to mention them again. It's open system authentication and shared key authentication. Now within shared key authentication, you provide mechanisms such as WEP, WPA, or WPA2 to authenticate and encrypt data between a wireless client and an access point. However, the password must be pre-shared. And this is already common knowledge that, for instance, when you're trying to connect to your router, you usually have the access password sort of stored somewhere else, or it's on the actual device for the initial password. Now the authentication methods. WEP is now considered obsolete, even though it's still widely used. But it's a completely obsolete first generation authentication. It's recommended now that you use WPA2, but it's also acceptable to use the original WPA. The difference between them is that one uses TKIP encryption and the other one uses AES. What they refer to, I'll explain in a second. Now, the temporal key integrity protocol is the encryption method used by the WPA. It provides support for legacy WLAN equipment by addressing the original flaws associated with the web encryption method. It makes use of the web, but encrypts the layer 2 payload using TKIP and carries out a message integrity check in the encrypted packet to ensure the message has not been tampered with. The AES is the encryption method used by WPA2. It is a preferred method because it aligns with the industry standard IEEE 802.11i. AES performs the same functions as TKIP, but it is a far stronger method of encryption. It uses the counter-cipher mode with Blockchaining Message Authentication Code Protocol, or CCNP, that allows destination hosts to recognize if the encrypted and non-encrypted bits have been tampered with. After that, WPA and WPA2 support two specific types of authentication. Personal, which is intended for home or small office networks. Users authenticate using a pre-shared key, a PSK, and wireless clients authenticate with the AP using a pre-shared password. No special authentication server is required in this type of connection. Secondly, we have the more professional and more corporate-based enterprise authentication, which is intended for enterprise networks but requires a remote authentication dial-in user service or radius authentication server. And of course, even though it's more complicated to set up, it provides additional security. The device must be authenticated by the radius server, and then users must authenticate using the 8021X standard, which uses the Extensible Authentication Protocol, EAP, for authentication. Now these are some fields that are necessary to supply the access point with the required information to contact the AAA server. The radius server IP address, the UDP port numbers, officially it's 812 and 813, but they can also operate under 1645 and 1646. Lastly, we have the shared key, which is the password that's used to connect the access point with the radius server. And that's it for the Chapter 4 video covering the basic topics of wireless LANs.